So let us now go for the software that we can use for calculating the sample size. So I will present a couple of them. So the first one I will just mention, this is this NCSS, that is the company, PASS, that is the name of the software. And this software, we see that it asks the kind of questions that we expect. So what is the power, what is the alpha, what is the means of each one of the groups. So this difference is actually the gap that we want to detect. What is the standard deviation? And there are many possibilities here for calculating the sample size. And so we may, the one that we have been explaining is the one for a two sample t-test assuming equal variance, or even in the case of the lesion of the cutaneous lesion, we were using different variances. So you see that depending whether your variance is one, so that you have the same variance or you have an equal variance, the option in the program is different. And the reason is that the calculations are different. So this program, the help is free, so you can find it in the internet. And then it has very detailed help. So it shows whether how to make these calculations. Or for instance, it shows, okay, what is the null hypothesis? The null hypothesis is that the two means are the same in both groups. And what are the alternatives? The alternatives is that they are different, that one is larger than the other, or the one is smaller than the other. And you will compute the t-value. This is the t-statistic that I meant before. So once you have done your experiment, you will compute the mean of one of the groups, the mean of the other, the variance of one of the groups, the variance of the other, and you have the sample size in each one of the groups, and you will compute the t-value. If the t-value is larger than a critical t-value, then you will reject the null hypothesis. And this reasoning, you can invert it to calculate the sample size, and this inversion somehow involves these distributions that we have been talking before. So if there is no difference, this t value, this t statistic, will be distributed with this distribution, and when there is a difference, then it will have a difference distribution, and this will be the critical value. So if the t value that you calculate in your experiment is beyond this point, then you will reject the null hypothesis. If it is not, then you will not reject the null hypothesis. The probability of making a false positive is this alpha. The probability of making a false negative is this area, has not been highlighted, but this area is beta. And okay, aside from the details of the calculation, there are a couple of things that I would like to mention. First one is that, okay, the calculations may look complicated, but the important thing is that I'm able to map my problem into this problem, because the calculations really depend on the kind of comparison and the kind of data that you have. So for instance, let's think of the example of the cutaneous area lesion, cutaneous lesion area. So there's an example when these calculations apply. So researchers wish to compare two types of local anesthesia to determine whether there is a difference in time to loss of pain. Okay, what I want to detect is a difference in lesion area. Subjects will be randomized to treatment. The treatment will be administered and the time to loss of pain measured. Okay, so I will measure the lesion area. The anticipated time to loss of pain for one of the types of anesthesia is 9 minutes. So my control would have 50 millimeters squared of lesion area. So far so good. The researchers would like to generate the sample size for the study with 90% of power, the same as me, to reject the null hypothesis of equal loss of pain time. So in my case would be equal lesion area if the true difference is at least 2 minutes. This is the gap that I want to detect. My gap was 25 millimeters squared. How many participants are needed to achieve 90% power at two different significance levels? Past experiments of this type have had standard deviations in the range of 1 to 5 minutes. So in my case, the standard deviation that we set the variance. The variance is 1000. The standard deviation is the square root of the variance, and this is an important observation. That is, it is true that you have not done your experiment, so it is true that you don't know what is the standard deviation that you will observe, but it is also true that you need some kind of range for the standard deviation. So we fixed our variance to 1000, so the standard deviation is square root of 1000, that is around 33, and you will have a range. So this 33 is not written in stone, so could be the standard deviation could be, I don't know, 25, 30, 35, in that range, and that range will give you a range of sample sizes. So yeah, I have been able to map completely my problem of lesion area into this example. So then that is the calculation that I want to do. And the second observation that I want to make is that this is the procedure 422. Actually, in this program there are more than 1,000 ways of calculating the sample size. You don't need to know all of them by heart or even understand all of them, but you need to understand that this mapping of my problem into something that can be calculated has to be done, and I have to choose the right calculation way. So this is one of the most common comparisons, so these two sample t-tests with equal variance, but you have to be aware that depending on how you will analyze your data, you will have to calculate the sample size in different ways. PASS is a commercial software, so you will have to pay a license. It is not too expensive, but most of the institutes don't have it. So there is another more used software, that is this GPower. GPower is free. It works with Mac and Windows, and maybe the documentation is not so extensive as the other one, and also it is not as simple to use, in the sense that sometimes the questions that it asks they are a little bit technical and we don't know what to put. But okay, so let's use it here and see how it goes.